So now let's go to the next one. So next one is continuity and differentiability. So continuity. So when do you say a function is continuous? And you say a function is continuous at a point or in the interval. But now we'll be studying, you'll be studying at a point, okay? So you take a function, you say a function is continuous at a point A. Because when if f of a exists, first point is f of a exists. This is your first point. Next, if limit extends to a, f of x is equal to f of a. That is your second point. And then your right hand limit, which is, don't get confused with this one, limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a. So this is the third point, okay? This is actually this point, do not confuse with this place. Okay, so you have three conditions for you to tell whether the function is continuous at a particular point. So you say a function is continuous at a particular point if f of a exists. Next, limit extends to a, f of x is equal to f of a. Then your right hand limit should be equal to the left hand limit, that should be equal to the f of value. Okay, now next what we can do is we have to find what is discontinuity. So in questions they may ask you to tell where is the discontinuity point, or is this function discontinuous or not. So they will rarely ask you that is this function discontinuous or not. Mostly they'll ask you to find at which point it is discontinuous. Okay, so that we have to study it really well. Now, you say a function is not continuous or discontinuous at a point A when the following things happens, okay? When your right hand limit or left hand limit exists, but they're not equal. So your right hand limit exists and left hand limit exists, but they are not equal, okay? They're not equal, but they exist, okay? And next, what is the left hand limit and right hand limit exist and equal, but they're not. Your left hand limit and right hand limit exist and they are equal, but they are not equal to f of a, okay? In that case also you can say it is discontinuous. Now other cases when we cannot find f of a itself, then you can say limit does not exist, which is discontinuous function, okay? And fourth point is at least one of the limit. It is not necessary both should exist. At least one, if doesn't exist, then you can say it is not continuous. So you have 4 points. Both the limits exist, but they not. First, you can start with this. Both the limit exist and they should not be equal. At that case, you can say it is discontinuous. Both the limit exists, they are equal, but they are not equal to f of a. Then you say it is discontinuous. F of a is not defined, then you say discontinuous. And last point is the limit, right hand limit or left hand limit. Now let's go to the discontinuous functions. Types of discontinuity. So there are 3 types of discontinuity. So it is removable. They said removable discontinuity. So what is removable discontinuity is nothing but when LHS, which is right hand limit, left hand limit is finite. Finite means that those both exist and they are equal, but it is not equal to f of a, then you say it is removable. So basically they are saying this is removable. This is removable type of discontinuity. Now, what is discontinuity of first type? Discontinuity of first type is those both limit, left hand limit and right hand limit exist, but they're not equal. So this is first type. Okay, so this is first type. And now second type is at least one of the LHS, that is right hand limit or the left hand limit does not exist. Then you say discontinuity of second type. Okay, so these are the types of discontinuity. Now let's see what is differentiability. So you say like for a function to be differentiable, it is mandatorily, it is compulsory that it should be continuous. So only when a continuous function, you can say it is, so if it is continuous, so only a continuous function can be differentiable, okay? And it is not, so if it is continuous, we cannot directly say it is differentiable, okay? So about that, let me come later. Now let me tell you about what is differentiability. So differentiability, so you say a function f of x is differentiable at a particular point if derivative f dash of x exists. So you say a function is differentiable if you have derivative, if f dash of a exists. So f dash of a can be found by limit h tends to 0, f of a plus h minus f of a by h, okay? So a function to be differentiable at a point in its domain, it must be continuous. As I already told you, it should be continuous. For a function to be differentiable, it is mandatory that it should be continuous at a particular point. But vice versa is always not true. So what they're trying to tell you is, you have a function. So you have a function, you say it is differentiable. If it is differentiable, you can definitely say it is continuous, okay? But if it is continuous, it cannot always be differentiable. It can be, so it is if you have, if they've given you a function, so if they tell you that it is differentiable, then definitely it will be continuous function. But if they gave you a continuous function, it may or may not be differentiable. It can be differentiable or it cannot be differentiable also. But if they have given you a differentiable function, then it definitely should be continuous, okay? So, but this is may or may not. It can be, or if it is continuous, it can be differentiable. It cannot be differentiable also. So, examples I'll be like, for while solving questions, I'll be telling you the examples. Now we'll be talking about differentiability on an interval. Okay, so a function is said to be differentiable in the open interval f of a comma b. So you say it is differentiable in the open interval f of a comma b if it is differentiable at every point inside the interval. So you have an interval a and b, okay? You have two intervals a and b. Among this, you inside this you have many points, right? So in all these points, it should be differentiable. Then only you can say that it is differentiable in the interval a comma b, okay? So are you clear with the differentiability in the interval? Just put I. Till now, if you're clear, just put I clear, because interval, just I'm talking about interval. And these are the formulas for the left hand limit and right hand limit left hand differentiable limit and right hand differentiable limit. So write I clear. So are you clear with this one? Are you clear? Okay, I just got one reply. What about others? Okay. Okay, fine. Now let's go to the next one. The properties of differentiable functions. So what are the properties? So just note it down immediately that every polynomial functions exponential function, constant function are always differentiable. So in exam, if they give you x square plus 1 plus x and just they ask you whether it is differentiable or not, you can just tell it is differentiable, because every polynomial, you can take any polynomial function and any exponential function. Exponential function is e power something, okay? So any exponential function and any constant function. Constant function is 1, 2, 55, anything. So if you take any polynomial function, any exponential function, and any constant function, it will definitely be differentiable at each point of the line. Okay. Now, let's talk about the next one. So logarithmic function and trigonometric functions are differentiable in their particular domain only. So you have particular domains for sine, cos, cosine, tan, right? Only in that interval it is differentiable. If they have given you some other interval and if they ask you whether sine or cos is differentiable, you can directly say that it is not differentiable. Only in the particular interval the log functions or the trigonometric functions are differentiable. Okay. So you have two functions. What about the third point is you have two functions and both the functions are differentiable. Then their subtraction, addition and multiplication is also differentiable. Okay. And now composition of differentiable function. That means f of g of x. So if g of x is differentiable, then f of x is differentiable. Their composition is also differentiable. Composition is nothing but like f of g of x. You're writing instead of x, you're writing another function. You're just substituting another function. That is basically composition. So composition of the function of differentiable functions is also differentiable. And when it is not differentiable, so a function is not differentiable, but it is continuous. So I already told you, right? It can be continuous. I already told you in this one, it can be continuous, but it may or may not be differentiable, right? So it can be continuous, but it may or may not be differentiable. So for that, if f is not differentiable, then you can say because when you have a sharp corner in the point. So for example, if you draw a graph, let me tell you, if you draw a graph, for example, if you draw a graph, you have a sharp corner. It may be like this or like this, any sharp corner, and the function is continuous and still you have a sharp corner, then you say it is not differentiable. Okay, so you have a continuous function and after finding it is continuous, you draw the graph and you find a sharp corner in the graph, then you can directly say it is not differentiable. Okay. Now, if both the functions are differentiable and the addition and multiplication at the particular point is also differentiable. So are you clear with the properties? So if you're clear with the properties, just write P clear. So these properties are important for you to solve the sum easily. So when you see a constant function, a polynomial function, just directly you can write it as differentiable. If it is differentiable, definitely it should be continuous. Okay. But if it is continuous, it may or may not be differentiable. So just write P clear. So write P clear. Okay, good. So now let's go to the next one. So relationship between continuity and differentiability. Okay. So a function is differentiable. Then I already told you, if a function is differentiable, you can say it is definitely continuous. But converse is not true. So if a function is not only continuous, it's only continuous. So the converse, I told you the reverse order is not true. But if they say a function is differentiable, you can definitely say the function is continuous. Okay. A function is not differentiable. If you're having a function and it is not differentiable, as I told you, it may or may not be continuous. Okay. So if you have a function and it is not differentiable, you can say the function may or may not be continuous. And if it is not continuous, then definitely say it is not differentiable. Okay. So I think it will be confusing for you. For example, remember it like DC. Okay. You remember it like DC. So if it is definitely differentiable, then you can say it is definitely continuous. But if it is not differentiable, you can say that it may or may not be continuous. Okay. And if it is not continuous, then it is definitely not differentiable. So this, you have to remember this trick or this shortcuts for your exam. And now left hand limit and right hand limit of f of x are finite, then f of x is continuous. If your left hand limit and right hand limit, they may or may not be equal. So if they're finite itself, then you can say that it will be continuous. The function will be definitely continuous. Okay. So are you clear with the relation between continuous and differentiability? So if you're clear, just tell R clear. R for relation. So are you clear? So if you're clear, just tell me R clear. Okay. So these are the differentiation of basic elementary. So these are the differentiation formulas. You can just write it down. And UV method, U by V method, everything is written. So you can just write it down, the formulas later. And this is a scalar product. You can just take the scalar outside and differentiate it. And differentiation addition, just differentiate it and add it. Multiplication is UV method. We already know that V dash U plus U dash V plus V dash U. Same way that is given. And this is V dash U minus U V dash by V square. So that is the same formula, quotient rule. And these are just formulas. And if you have differentiation in this type, you can just substitute A cos theta or A sin, instead of X, you can substitute A cos theta or A sin theta. And even same way for X, you can substitute A sec or the corresponding trigonometric values. You can just note it down. These are just formulas. So even this is just formulas. We'll be sharing you the material, so you need not worry. So I'm just brushing through quickly. And now this is, in previous class, we studied about, right, about the quadratic equation. If you have root, that quadratic equation you have studied. But here we have to find the derivative of infinite series. So finding the derivative of infinite series, what we can do is, we can write y is equal to root of g of x plus y. Okay. If you have this one and you have addition, you can write it as addition. If you have subtraction, you have to change it as subtraction. So you have to write it as g of x plus y. Okay. And now we have to take square root on both the sides. So it will be, and this y goes to the other side, it will be y square minus y is equal to g of x. Now what you have to do is, you have to differentiate on both the sides. So when you differentiate on both the sides, you will be given with the answer. So you can directly remember, if it is 7 plus 7 plus root of 7. For example, I'm telling you just 7. Instead of 7, you can have even cos theta or cos x, sin x, any function value you can have. For that, what you have to do is directly differentiate with respect to x or any variable. So if example, if you have cos theta, you have to differentiate with respect to theta. And for in given value, you have to just substitute by 2y minus 1. That's all. Nothing else. So this is your differentiation. Basically, these are the steps. Okay. How to do, for example, if you have subtraction, you have to just put subtraction, like minus symbol. Okay. So that's all. Now let's go to the questions part. So evaluate the following questions. So now limit root of, you have 5 options here, like 4 options. So limit x tends to 2, root of 1 plus 4x minus root of 5 plus 2x by x minus 2. For that, what I'll do is, when I substitute 2 here, it will be of 0 by 0 form, right? So if it is 0 by 0 form, I told you, you can just cut down the, what you have to do is, you can just cut down the common terms, or you can use L hospital rule, or you can use rationalization method. So here, if I differentiate, if I use L hospital rule, I have to differentiate the numerator. It'll be really a huge task. So for that, what I'm doing is, I'll just directly rationalize it. So I'm rationalizing the numerator. So what here, it is root of 1 plus 4x. So I'm rationalizing the numerator. So I'm multiplying this with the opposite sign in the numerator and the denominator. So what it becomes is, it will become 1 plus 4x minus 5 plus 2x. Okay, and denominator becomes like this. Now further, what I'll do is, I'll remove the signs, remove the brackets. So it'll be 1 plus 4x minus 5 minus 2x. Okay, so it become minus 4 plus 2x. So when I take 2 outside, it will become x minus 2. So that's how this came. So it becomes x minus 2, and denominator, what happens is, when I substitute 2 here, so what will happen? 1 plus 4 into 2 plus root of 5 plus 2 into 2. So it becomes root of 1 plus 8 plus root of 5 plus 4. It becomes root 9 plus root 9. It will be 3 plus 3. It will become 6. That's how this 6 came. And basically, this and this will get cancelled. So 1 times and 3 times, it will become 1 by 3. So your option is option B. So option B is your correct answer. Okay. Now, are you clear with the question 1? If you're clear with the question 1, quickly write 1 clear. So yes, if you're clear with the question 1, write 1 clear. So later you can go through the steps clearly. So if you're clear with the method, what we used for the sum, just write. And basically, I'll give you just one tip is, when you're having root, do not use L hospital. In rare cases, you use L hospital, because if you're having root and you have to use L hospital rule, you have to differentiate. Then it will take a longer process. For that, you can use rationalization. So for square root, prefer, for any root, prefer rationalization than L hospital rule. Okay. Now, let's go to the next one. Next one is evaluate the following, and you're having roots, and it is again in 0 by 0 form, right? So it is again in 0 by 0 form. So what I'm doing is, I am factorizing. So when I factorize this, so these are very small roots, right? So you can factorize, but as in previous case, it is a huge root, like it is a bigger root. So it is very difficult to factorize, and you cannot factorize this. So what I'm doing is, I'm just writing this to 4 as 2 square, and this I'm writing, this is x, not root x, this is x. So this x, I'm writing it as x root x power the whole square. Okay, so that's how I express this. So this is of the form a square minus b square, which is a minus b into a plus b. Okay, and now what I'm doing is, now basically I am splitting it as a minus b and a plus b. So I'm just cancelling the common terms. Now it will become 1 by 2 plus root x. Now if I substitute the limit value, it will become 1 by 2 plus root 4, which is 1 by 2 plus 2, which is 1 by 4. That's how I got 1 by 4. So this sum, when you look at the sum itself, you can find it as like this 4 is 2 square. And this x can be expressed as root x into root x. So you can directly factorize it. Okay. So in previous one, you cannot factorize this. So you have to rationalize. So are you clear with the second question? If you're clear, just put 2 clear. So your answer is 1 by 4. So option A is your correct answer. So are you clear? Okay. Now let's go to the next one. So by looking at the sum, can you tell me, do we need any determinant, indeterminate forms to solve the sum? Or you can just give me the answer quickly for the question number third sum. Right? Question like 3, option A or B, something like that. Because it's actually simple sum. So question number 3, try to solve it on your own because it's actually simpler sum. You don't need any indeterminate forms to do it. Okay, so most of you have told option A. Okay, so yes, option A is the correct answer because it is not of indeterminate form, not an indeterminate form. We can directly substitute 1. It will be 1 plus 8 by root 1, which is root 9 by root 1, and which is 3 by 1. So your answer is option A. Option A is the right answer. But in questions, so actually, Sai Subramanian recorded videos are already in the app itself. You can just go directly check them. So recorded videos are there in the app itself. You can go directly check them. So yes. Now let me go to the next one. Next one. So yes. So is this of in okay, just a minute. I'll just we'll talk about it later. Sai Geeta and Sai Subramani we'll talk about it later. Otherwise, like you just give a call after this class. Like we'll explain you like how to do it. Okay. Okay, okay, Sai Geeta and Sai Subramani, I'll just tell it might be a bug, so I'll just tell you. I'll let you know. We'll give a call to you. Okay, Sai Subramani and Geeta will give a call to you about the recorded classes. Okay. So yes, I'll just note it. Okay. Okay. Now let's start. So evaluate the following. Now it is of 0 by 0 form. So numerator will also become 0, denominator will also become 0. So it is of 0 by 0 form. As I already told you, if you have a root, do not take any other options. If you have a bigger root like this, do not take any other option. Just directly rationalize it. Okay. So what I'm doing is the numerator, I'm rationalizing it. I'm rationalizing it. Now what happens is, numerator will become a plus x minus a by x root of a square plus ax into root of a plus x plus root a. So this a and this a gets cancelled. That's how it became like this one. Now what happens is, after this, what we are doing is I'm cancelling this x and this x. So it turns out to be 1 by root of a square plus ax into root a plus x plus root of a plus x plus root a. Okay. And now what I'm doing is I'm just directly substituting 0 for it. So it will be root of a square plus 0 into root of a plus 0 plus root a. So it becomes root of a square into root a plus root a. So it will become 1 by a into 2 root a. That's how it became as 1 by 2a root a. Both are same. So your option is option B. So did you understand the concept? Like, are you clear with the question? Question number 4, clear. Just write it. Question number 4, clear. If you're clear, just write it.